At Becht, our mission is simple: deliver technical excellence to our clients worldwide. From the oil and gas sector to refining and industrial processes, we provide engineering solutions that make a difference. Our expertise extends to plant services, training, and software tools, always striving to exceed our clients' expectations. At Becht, we combine cutting-edge technology with a team of experts dedicated to safety, efficiency, and innovation. Our commitment to training ensures that our teams and clients are always a step ahead. Becht, more than a company, we are your strategic partner in engineering and plant operations. Becht, good, better, Becht.
Good evening to most of our Inspnet followers all around the world, and also good morning and good afternoon to all of you who are joining us from different parts of the world, as we have followers all over the planet. Thank you so much for being here today. We have an excellent panel about the future of energy, the essential role of hydrogen and renewables, and we have an amazing set of guests that are joining us. We have Daniel Loaiza, the Senior Communications and Marketing Manager at ENG Mexico, Horacio Pinzon Coronado, Hydrogen Business Developer at Ecopetrol, and Leonardo Uller, an Inspnet, a frequent Inspnet collaborator from Global Business Advisors at Cortest Inc. Thank you so much for being here with us. And just to remind all of our followers that this is being streamed simultaneously on our LinkedIn, YouTube channels, as well as the Inspnet platform. To start, Inspnet, the initiative of Inspnet is aimed at connecting our community with advanced technological information and knowledge. And to inform that this panel is the first of a series of 3 panels that we will be hosting throughout the rest of the year. I think it's really important that we mention our commercial partners who are joining us. We have gold sponsors such as Becht that exist to help our clients succeed. Becht builds trusted partnerships grounded in technical excellence with an owner-operator perspective. Becht has a global network of more than 1,000 subject matter experts delivering practical engineering solutions that improve safety, reliability, and profitability. Also tonight, joining us is Cortest. Cortest has been a leading company in high-quality corrosion and materials testing equipment since 1977. Cortest product line includes autoclaves, load frames, fume hoods, flow loops, deadweight testers, HIC tanks, magnetic drives, control software, and specialty equipment designed to fulfill industry standard testing methods. Cortest also provides reliable customized systems for corrosion testing in environments containing hydrogen sulfide and gaseous hydrogen under high pressure and temperature conditions using high quality materials. We also have ENG Mexico, who is at the forefront of the country's energy transition, leading the change towards a sustainable and renewable energy future. As a key player in the development and integration of low carbon and renewable energy solutions, ENG Mexico is committed to a just energy transition for all, enhancing energy security across the nation of Mexico. With a diverse portfolio that includes solar, wind, and innovative biogas projects, ENG Mexico is shaping the future of energy in their country. Finally, GasTech 2024 is the premier global exhibition and conference for natural gas, LNG, hydrogen, climate technologies, and low carbon solutions, featuring over 800 exhibitors. With more than 50,000 attendees, it serves as a major platform for showcasing the latest innovations and strategies to industry leaders and decision makers across the energy sector. The event highlights advancements crucial for the energy transition, and offers insights from both established technology providers and emerging startups. Right now, I'd like to take a quick pause, and Francesco Solari, the CEO of Inspinet, is going to give a brief greeting to our community and to our guests tonight.
Hello, Richard. Hello, everyone. I'm really grateful with Daniel Loaiza, Horacio Pinzon, and Leonardo for being here with us. We are really proud about the product and the connection that we are trying to offer to all our followers around the world. And today we have this great event. So I have to say thanks to all, thanks to our sponsor, and go ahead. It's the time for share knowledge.
Thank you so much, Francesco Solari, CEO of Inspinet. You've probably seen him on our social media channels as well as at the conferences we cover every year. We will soon be joining him for more content this month of September and also in October. Thank you again so much, Francesco. Next up, I'd just like to remind our followers who we have on tonight's panel. We have Daniel Loaiza, the Senior Communications Manager and Marketing at ENGIE Mexico. Horacio Pinzon Coronel, a hydrogen business developer at Ecopetrol, and Leonardo Uller, Global Business Advisor at Cortest Inc. Thank you so much for joining us, and we look forward to your participation on this panel. Right now, I just want to do a quick deep dive into each of these participants. Daniel Loaiza, he is the Senior Communications and Marketing Manager at ENGIE Mexico. He has over 20 years of professional experience in journalism, advertising, and corporate communications across various Latin American countries. After writing for several national media outlets in Venezuela, he has spent more than 10 years leading high-performance teams at advertising agencies, working for multinational clients, and producing award-winning campaigns recognized for both their creativity and effectiveness in Venezuela and Chile. In 2019, he joined ENGIE Latin America to coordinate communications and change management projects regionally: Mexico, Colombia, Peru, Chile, Argentina, and Brazil from Chile. In April 2024, he joined ENGIE Mexico to lead the company's communications in that country. He's going to be talking to us tonight about overcoming the intermittency for renewable energy growth. Daniel, are you here with us?
Yes, thank you, Richard.
Thank you, Daniel. Go ahead.
I'm trying to share my screen. Let me see let me know when you see it.
I see it.
All right. Thank you very much for the opportunity of being here. Thank you very much for creating this space. I'm going to talk about batteries. It sounds old school, but it's at the moment, and we're going to be talking about technology and related to hydrogen, but at the moment is the technology we have at hand for accelerating the energy transition towards renewables. A bit of context. We all know it. All major energy players are accelerating in the installation of renewable energy sources on two sides: to replace exiting coal and diesel and other more pollutant energy sources, and to cover new demand. We are seeing increasing levels of auto consumption. This all means instability in the system. And regardless of the environment, the energy world needs stability. We project that as soon as renewables penetration is about 30% in any geography, in any market, 0.15 gigawatt of BESS, of battery energy storage systems, are needed to balance every gigawatt of renewables added. When we talk about the ambitious goals that we have at many energy companies, of course, ENGIE being at the forefront of them, of replacing coal and getting new clients and serving new clients with renewables, we need to offer stability. Okay, but what are best? Battery energy storage systems. They store surplus renewable energy for use when demand is high and generation is low. And as we see below, and this is the paradox of solar particularly, that when peak demand is on, usually in the evening, is when the sun is out. So we need to balance this. We need the storage. At the moment, the industry is focusing on lithium-ion technology batteries. These are electrochemical batteries like many of the ones we know. What you see behind me is Latin America's largest battery energy storage system that we inaugurated in May in the north of Chile, serving the Coya photovoltaic plant. According to the International Energy Agency, in its net zero emission scenario, the need for flexibility solutions such as batteries, is expected to quadruple by 2035. Like I mentioned, the industry is not only us, many players are focusing on lithium-ion technology because it's the most efficient, the most easier to implement, and cost-efficient to operate. Okay. What are key benefits of this battery storage system? They stabilize the electricity grid, helping integrate more renewable energy. As we have these systems that stabilizes that can give energy to the grid when demand is high, to store it when demand is low, and we're generating at noon, like a case we have in Australia. You use these systems to stabilize everything. They provide support in emergencies because they guarantee availability of energy, long-term savings in terms of availability to plan. You can plan ahead on energy availability when you have these kinds of systems. So it is very helpful. And finally, and like I said, the technology is here and is constantly improving, but it's a technology that is mature. This is the issue that, and I'm sure we're going to talk about this a bit more, that we have with hydrolysis and hydrogen. We're not there yet with the technology. So, but we have very pressing needs to accelerate on renewables to replace carbon emission generation technology. So at the moment, this is what we're dealing with. And this is the best solution that the industry is offering to stabilize and grow in renewables. I wanted to share a few figures from ourselves, from ENGIE, what we have operating. Like I mentioned, we're inaugurating them in the past 3-4 years. We're developing and inaugurating these battery energy storage systems. We have 2 gigawatts as of June 30th of this year. We aim to reach 10 gigawatts by 2030 in Europe, the United States, Latin America, Australia, and South Africa. We're currently operating in Peru, a smaller 85 gigawatt battery storage system. In Chile, we already have one, the largest, like I mentioned, Coya behind me operating, and 2 more in development and construction, as well as North America. And in Australia, we have the Hazelwood battery storage system, which is a very interesting case because it does not serve a particular power generation plant, but it's fed by the surplus from the solar panels in the community surrounding it. So during the high noon, where consumption is lower residentially and production is highest, it is brought to this Hazelwood facility and then brought back to the grid at the times of peak demand, bringing costs down for the consumer. Like I said, this is the future that we have at our grasp. This is what we are, what we have at the moment to accelerate on renewables, and we at ENGIE believe that stability via the battery energy storage systems is key for the growth of renewables. And thank you.
Great, Daniel. Thank you so much. Really interesting content out of ENGIE Mexico. Are you in Mexico right now?
Yes, I'm in Mexico right now.
And you joined the team this year?
Yes, I joined ENGIE 5 years ago at the region, and the Mexico team this year. Yeah.
All right. Awesome. Well, that must be a really interesting opportunity. Mexico is a huge market, and they're definitely growing in terms of the global sector. Thank you so much, Daniel, for your information.
Thank you very much, Richard.
Okay, great. Well, to continue on with this panel, next up we have Horacio Pinzon Coronel. He is the hydrogen business developer at Ecopetrol. Horacio has a bachelor and a master of science in mechanical engineering with over 12 years of experience developing new technologies, mainly related to the oil and gas sector in Colombia, where he's been working for more or less 10 years. And in the last 5 years, Horacio has primarily focused on developing hydrogen pilot projects, being the director of Colombia's first hydrogen and natural gas blending project launched in March of 2022, and the director of Colombia's first hydrogen refueling station for bus rapid transit system in Bogota, launched in March 2023, and participating as a technical or business developer in many other initiatives in his current role at Ecopetrol, the primary energy company in Colombia. He's going to talk to us today about hydrogen perspectives. Horacio, are you there with us?
Yes, Richard and colleagues, how are you? Thank you for the invitation, and it's very nice to be here this night.
Thank you.
So I'm gonna share my screen as well. Please let me know when you all can see it, at least here in the master.
All right, I think we're set.
Okay, so I'm gonna talk a little bit about hydrogen perspective and putting some talking points regarding the essential role of hydrogen and, of course, renewable technologies in this future energy landscape. First, why hydrogen is important, and to understand that, we need to also understand what energy transition is. And for that, let's say that the current status of the energy used in the world means that the main energy carriers that we use today are fossil fuels, of course, but they are used as thermal energy carriers. If you see, for example, things like gasoline, diesel, jet, coal, and all the things that we use regularly in our technologies mainly are for thermal energy. And just a little bit are used for electrical purposes. So in that share, thermal energy is bigger than electricity nowadays. And if you see, if we double click on that, for both electricity and thermal energy, the fossil fuel part is the largest in comparison to the renewable part of the energy matrix. So energy transition means the merging of two trends at the same time. On one side, we have the electrification of users' end, meaning that new technologies enable the use of electricity for that user's commercial or industrial processes. But in the best scenarios, the net zero scenario and other dreaming scenarios, we have that the electricity share by 2050 would be roughly 50%. So when we imagine ourselves in a zero emission world, let's say, or operations, both for industrial or commercial purposes, the electricity share will be only 50%. That means that the thermal energy will be also the remaining 50%. And that's where the second trend also joins, and is that the offering will switch to renewable sources. So when the user's demand is electrified at most, and all the sources, or most of the sources, are now produced or sourced through renewable technology for both electricity and the other thermal energy processes, then we will reach those net zero scenarios. And hydrogen will be a key energy carrier, not only for electricity, because you can produce electricity from hydrogen, but also for thermal energy, because you can use it as an energy carrier for all the thermal or industrial processes as nowadays. And actually, you can burn hydrogen, for example, to produce heat as well. But in this landscape, of course, it will appear the chicken and egg problem, because you have to assure that there is demand for the new sources of the energy carriers and vice versa. Okay, so nowadays we are attacking this chicken and egg problem by two types of actions, let's say, and this is, for example, what has been the Colombians' experience at the moment. You can say there is an approach, some sort of technology push from the companies that are involved in the energy matrix in the country, and they are implementing pilot projects to make sure that the companies know the technology and they deploy those solutions to the market and get the market to know what hydrogen can afford or can contribute, sorry, to the energy matrix. And some sort of market pool approach, and I say pool because it's not that demand asked for hydrogen, but the demand is asking for regulation to use hydrogen afterwards the regulation is in place. So in countries like Colombia, we are focusing in pilots and of course promoting the regulation as companies to the government. When you see what has also been implemented in the world regard these strategies landscape, you find that the first one was Japan in 2018, and several countries followed. Nowadays, we have over 50 hydrogen strategies or roadmaps all over the world, primarily focusing on solutions for producing hydrogen or using hydrogen and transforming the industrial landscape in their countries. Of those strategies are located in Europe and Asia, but there are some examples in Latin America and Africa as well as major producers of renewable hydrogen in the future. The other approach, the tech pilots, let's see, for example, here what Colombia has implemented in the last few years. This is a platform that has been developed by the Energy Ministry, and it shows that right now we have 7 pilot plants operating with an investment over $10 million on just in capex on those 7 projects. And we have installed over 350 kilowatts of electrolyzers. Ecopetrol, just as an example, is the owner of 3 of those 7 pilot projects, most likely focusing in mobility, which is the SITP Renewables pilot, the first one on the right, and the Centro de Innovación Econova Cartagena Movilidad, which is also a mobility project experiencing with light-duty vehicles. The other one is the second in the row, which was developed actually, is now being used in the refinery for the reforming processes inside the hydrocracking and hydrotreatment plants. When you see what kind of energy has been used so far, you have solar, biogas, and some mix of solar and wind power. But these implementations were mainly done in 2022 and 2023. Right now, the country is shifting towards large-scale production in the country. And what's the price of all of this? Why doing pilots? Why pursuing a national strategy? According to the Hydrogen Council, the hydrogen market in 2050 will be 660 million tons of hydrogen worldwide, and providing over the 20% of the global final energy demand, which is huge, taking into account that right now in 2020, the 90 millions that are shown in this figure are not for energy purposes, but for feedstocks in mainly refineries and other industry uses. If you see that breakdown, the use of hydrogen will shift towards either new industry, but towards several energy-based applications like power generation or mobility. What's the current performance of hydrogen? Right now, despite the 50 plus strategies that has been declared or in deployment, the hydrogen production remains the same, just with current trend of plus 30% of year-on-year growth, and mainly produced by fossil fuel solutions like natural gas or coal. So far, despite that there has been a lot of declarations from several countries, the status quo remains quite the same. If you see, for example, what's the endeavor, if we compare the current status versus what is intended by 2030, you see that there is a gap, a huge gap that must be covered in the next 5 years, but also that the diversification regarding the industries that are using or producing hydrogen must change as well. Right now, most likely it's refining and other industries like steel, like fertilizers, that are the common users of hydrogen, are the ones that are also using it most likely in the future. But things like power, steam fuels, or transport need to accelerate their deployment. For example, if you see over here, in detail for refining sectors, you see that there is a huge gap between what is needed by 2030 and what is currently implemented. That is not even noticeable here in the graph. You see here in the left, and the new capabilities are also installed in current technologies plus carbon capture. When you see, for example, other industries, you see, for example, here that the decarbonization initiatives remains quite very low, and most likely there is a major push in the industry sectors to keep the use, maybe keep the trend of usage of hydrogen, but to push further on decarbonization and make sure that they capture the CO2 generated, or finding another way to source hydrogen from renewable sources. A good news may be transportation, which has been the first major business unit that has been pushed worldwide. They have doubled the installed capacity from 3 years ago, or compared before the pandemic times. But you see that the contribution keeps around 30,000 tons a year. That is quite low in comparison to the 90 million produced yearly worldwide. And that application has remained or has been developed in countries like China or Korea, most likely Asia, which are forcing towards new technology like electric vehicles or hydrogen powered vehicles. For example, I had the opportunity to visit Korea last year, and what they have been doing is to push this technology on the end user side, but keeping current ways to produce hydrogen and maybe capturing the CO2 associated with that, meaning that they don't have shift towards a pure renewable or completely renewable source. They keep the natural gas as base to keep the offering competitive, but they have sure to install the technology to diminish the carbon footprint on that operation. So there is like a quite interesting balance between the technology change of the demand and being competitive overall. The price over there right now, as per last year numbers, is like $20 per kilogram. And the target worldwide would be that the hydrogen provided for mobility solutions is less than $10. So there is a lot of gap to cover by the industry as well. And you can see it, of course, here when you compare the total demand that has been intended by all these policies is around 14 million tons of green or renewable hydrogen by 2030. But the production targets of the same policies or the same declarations of the country is above 30 million, it's roughly 35 million. So there is an asymmetry between the demand and all the policies that are pushing for new demand and the production targets, and that gap must be fulfilled by more policies or agreements. If you take into account also what has keep this performance so low on the energy side, you will say that the final investment decision is very difficult to reach. And in terms of that, when you see a lot of projects that has been announced worldwide, if you see this, the picture on the left, sorry, you can see that there are a lot of uh, orange colors and yellow colors, meaning that they are in a very, very early stage of development. And if you see the green projects worldwide that are operational, they are super tiny squares, meaning that they are at the pilot scales or very tiny operations, less than 50,000 tons per year. In the case of the Colombian case, I think the total amount of hydrogen produced today in these pilots is less than 3 or 4 tons a year. So it's very low in terms of production, and most likely it's because it is very difficult to find or to reach the final investment decision, as you can see on detail on the right. By the numbers of the International Energy Agency, it is less than 4% of the total projects that has been announced somehow or in the world. Less than 4% has been declared as or has reached the final investment decision and are now in the construction stage. Off-taking is also a problem. You have, or the policies demand for a production target, but the off-take agreements are quite low. It's less than 10% of the targets, and it's also pushed in terms of the things that we have to do in terms of the market to keep the hydrogen going. Most likely is regarding a competitiveness issue, and most likely the renewable hydrogen remains 4 times up to 10 times higher at the cost in comparison to the traditional gray or blue hydrogen. So we have to push for diminishing the cost, the levelized cost of the renewable hydrogen, most likely by making sure that the technology is right there, that we can capture efficiencies producing this new technology, most likely electrolyzers. As my colleague before me mentioned, the best solutions are also required to diminishing cost. So the overall cost of producing hydrogen from renewable sources meets the target required for large scale massification. How cheap has to be the energy? Today we use the energy or the electricity around $50 to $60 the megawatt hour, but that number we have to push it below $30 megawatt hour, if you see on the graph on the left, to make sure that the hydrogen cost is around $2 per kilogram, so it meets the current gray or blue hydrogen numbers and therefore being competitive. For that, and this is my last slide, we have to push the policies further and increase the R&D investment worldwide so it can reach interesting numbers and we can develop the technology and develop new business models so we can make the hydrogen cost competitive regarding not only the traditional ways to produce hydrogen, but also regarding other current fuels or conventional fuels. And then the demand is also capable of transitioning to these new energy carriers. Thank you very much.
No, thank you. Really interesting content. And Horacio, just to touch on rapidly at the beginning when I introduced you, part of your introduction mentioned that you were working on hydrogen refueling for the rapid bus transit system. Is this the famous Transmilenio?
Yes, it is the famous Transmilenio bus that we have here in Colombia. Yeah.
Well, but soon Bogota will have a metro, if I'm not mistaken.
Yes.
Well, great to know that you guys are working on such excellent public transportation initiatives. Horacio, thank you so much once again.
Thank you.
Great. So moving on, before we dive into the question section, we have Leonardo Uller. He is the Global Business Advisor at Cortest Inc. He's also a chemist, a master in metallurgy and materials, and a doctor in chemical engineering from the University of Paris. He has dedicated more than 45 years to studying corrosion mechanisms and their protection and serving industries to solve these problems. He is the CEO of Surplus Technologies in Rio de Janeiro in Brazil. He's the former board director of AMP, and he was also elected 3 times for the position of at the board of directors of NACE International. He received several international titles and recognition, including the Fellow Honor from NACE International, and is an international consultant in materials engineering and corrosion. Here he is here representing Cortez. Currently, he's the chairman of the AMP project dedicated to the guidelines for laboratory materials testings in hydrogen. Leonardo, thank you so much for being here with us. I see he's got his presentation up already, and the topic is the importance of standard procedures for materials testing in hydrogen gas. Leonardo, thank you so much for being here with us.
Thank you so much. Also, thank you very much for Inspinet and the opportunity to be here sharing this experience with our colleagues. I will be reduced to 10 minutes. I'll try to do it. And this is the description of our process is. The hydrogen is an alternative of fossil fuels used in the process, as you know, and probably in the future in the vehicles. Attention, what is the problem now? The problem now is the transportation and storage sectors. We're limited in some instance to these fields. The hydrogen gas is being introduced into the existing natural gas pipeline. This is another problem, and its effect on the integrity of these pipelines is the area of active research, because hydrogen can damage materials through hydrogen embrittlement. This is highly variable based on stress, pressures, and temperature. Siga. Well, how to evaluate the materials? Well, we are talking about a lot of things, a lot of materials, and a lot of devices and equipment using in the future in contact with hydrogen. Well, to develop or evaluate materials that can withstand hydrogen embrittlement, research is required for sure. Many groups of universities, they are doing very, very interesting work and distributed all in Latin America, in South America, North America, Europe, in Asia also. To guide laboratory experiments with greater rigor and controlling parameters is needed, is a need. More procedures of homogenization and better observation of the results of the studies to facilitate materials performance comparison. There is no comparison. There is a lot of papers, a lot of results but we need to know better about the mechanical and the corrosion problems we can have with the use of hydrogen. And also, the safety is necessary in the lab to avoid accidents. The next. Well, at the end, we said, oh, we need testing procedures. Well, how can we make this? We detect that we need to have the standards, we have procedures to recognize and to make comparisons. So a guide that addresses the testing of materials for characterization of the mechanical factor properties under combined action of static and dynamic tensile stress. The problem is the stresses that we can have with hydrogen gas. And the main purpose of this guide is what? This is important, to facilitate conformity in testing. So we need to compare what we are doing in academia and also in the industry. We see a lot of equipment and devices that the company said, oh, this is okay for their use with hydrogen. But we never know. They did experiments, they tried, they are certified for that. We never know. We need to contribute evaluation and selection of all types of metals and alloys. regarded as a application for service in hydrogen environments. Siga. Well, so then in the end of 2023, we proposed a project through AMP, the Association for Materials Performance and Protection, that joined with the merger of NACI and SSPC. This project was approved in the Standards Committee 26, Carbon Capture, Alternative Fuels, and Energy Storage. Again, next. Siga? Well, what is the scope of this guide? This is just for testing mechanical dangers of materials caused by hydrogen at high pressures and temperatures, using autoclaves for that, for high pressures and high temperature, or other devices in lab. Well, this guide will contain methods of testing using tensile and bend beams and used to compact tension fracture mechanics test specimens. This is very important for the future. It's intended to use in lab in materials personnel to facilitate the conformity in testing. Siga? Well, this is another point, very important things, that we need to have the cooperation with other groups. We'll take advantage of working together is better. And then our standard, the guideline, we are in touch with the European Structural Integrity Society, and also represented by Dr. Milos from Belgrado University. He's a specialist and is the chair of TC21, the Hydrogen Environment Transport of this European society. And also the European Pipeline Research Group. The chairman is Dr. Bastian Bezansky, just doing a very good job. And they finished, the IPRG finished last month this first guideline for the use of hydrogen. So these people are in contact with us, and it will be great to have the voting process in the future of this standard, the cooperation of these groups. Siga. Well, there is a very good discussion of international research groups. Well, we can see people from Shell, people from SINTEF in Norway, and University of Oxford. They did a very interesting seminar last month, and also the people from the other side, from the University of Belgrado. So we can discuss things for topics that will intervene in the examination and the trials of our guidelines. Next. Siga. Well, what kind of devices? We need to make the standards for the use in high temperature, high pressures in hydrogen for the autoclaves, existing autoclaves, because it's dangerous. We need to have the ability and we have the guidelines for how to use with safety, how to use with procedures that we can compare with other groups. Next, please. Siga. Then, Cortez, 3 years ago, developed a hydrogen test system. This is the first system that was developed in the world. It's fantastic. It's a big job. There is a test system that we can use this inside the lab with all safety and all kind of examinations using the load frames, applying using for fracture and fatigue, and also using autoclaves and do examinations and trials in high temperature, high pressure. Next. Well, the project timeline, we start in February 2024, and our goal is July 2025. Say, no, it's 1 year to do a standard. Yes, AMP has changed completely. In the old years, in NACI, we spent 5 years for a standard. Now we have 1 year or 2 years to finish the standard. I'm expecting to finish the process, the voting process in July 25. The group is very interesting, and I think I invite people to join this project. Next, please. Well, here's my contact. And if you want to participate of this group, participate of this task group or this project, please be in touch with us. Thank you very much for your patience and for your attention.
Dr. Leonardo, muito obrigado. Thank you so much for your time and for your presentation. And so that wraps up essentially the three presentations from our three experts. Leonardo Ured from the Global Business Advisor at Cortez, Horacio Pinzon Coronel, Hydrogen Business Developer at Ecopetrol, and Daniel Loaiza from ENGIE Mexico. Okay, thank you so much for your contributions. Really interesting content. Next segment of our talk tonight, we're going to have a small discussion where we're going to have a few different questions, and well, if we have any comments, we can get to those as well. First off, Daniel, you're here with me?
Yes, I'm here.
Awesome, great. So just a few quick questions. The first one being, how is ENGIE integrating battery energy storage into its renewable energy projects? And what role would batteries play in managing intermittency and stabilizing the electrical grid?
Like I mentioned, newer renewable projects, especially solar projects, are already considering battery energy storage systems as part of it to deliver a complete package of renewables with stability, with flexibility, with the capacity to supply the market it's serving without being intermittent, which is the largest risk that we have. The second part.
Yeah. Second question: what technological advancements in batteries does ENGIE consider crucial for accelerating the adoption of renewable energies and achieving a successful energy transition in Mexico?
Like I mentioned, Mexico is full of opportunities for growth. There's a big talk about nearshoring in Mexico now. This growth means more, hopefully, in this new, and we believe with the new government coming in, that we're very aligned in that strategy, in the energy transition and growth, sustainable growth, basically. So we already operate a small test battery project in the north of Mexico. We believe there are many areas to cover in our market, but in terms of growth, we believe renewables with battery systems are crucial for it, and we're at full availability of the state to start working on these projects. And we have plenty of experience in other markets that help us there. Technologically, like I mentioned, the lithium-ion batteries are a mature technology. So these are 10 years, around 10, 15 years lifespan of these technologies. Like I mentioned, we're waiting for the hydrolysis breakthrough to bring us green hydrogen sustainably in enough quantities to cover the huge demand that we will have. But in the meantime, optimizing the lithium-ion technology that is the standard now, making it more cost efficient, ensuring that in terms of supply chain, we can cover all this demand that we project that we will have from here to 2030, 2035 and beyond.
Do you foresee sodium ion batteries playing a role in this as well?
Maybe. Many technologies are being tested. This is, like I mentioned, lithium-ion is the standard. But we live in, and we're lucky for that. We live in an era of breakthroughs. So when this breakthrough comes and makes this other technology cost efficient, easier to implement, and serves us in stabilizing the grid, I'm sure we will we will adopt it. If you notice in the past few years, energy companies, we have been adjusting our targets, and it varies because of technology and availability. We have projections, but counting on some breakthrough or some cost structure that will allow us to implement it there. When we see that we're not getting there yet, or we are moving faster than we thought, we adjust our targets. But the main goal is to accelerate the energy transition.
Awesome. Danielle, thank you so much.
No,
Next
thank
question
you very much.
for Horacio. Talk to us about the current status of hydrogen as a new energy business in Colombia. Where does that stand?
Yes. So as I showed in the third or fourth slide, you could see there that right now there are 7 projects operating in Colombia, that they were mainly implemented in 2022 and 2023. And then we realized that we could like aspire for something bigger, as Daniel was mentioning. I mean, this energy landscape seems to be very interesting. And in terms of Colombia's potential, the renewable resources are right there. So the companies in the country try to shift towards not doing like small scale pilots, because any other companies were also implementing them, and it's kind of, we are going to learn from their results, and to start to target bigger and bigger projects. And then the technology is not getting cheaper as we think it will become, and the energy or the levelized cost of energy is not as cheap as we thought it would be. And all the energy, electricity-based projects are also like in some sort of slowdown state. So Colombia is some sort of stopped of doing pilot projects. That I think was the right trend or the right path in terms of knowledge and developing and getting to take a first glimpse of the technology by yourself, and completely shifts to develop larger and larger projects. And there you have all the issues that Daniel was mentioning before. The technology has to get cheaper and cheaper, to being able to source all the elements. And above that, not only for hydrogen, but also for electricity, because in terms of producing renewable hydrogen, you need, for your cost share, you need that electricity is super cheap at the 70% share or something like that. So the prices are, as mentioned, Colombia has typically prices very above the $30 per megawatt hour. So we are kind of developing the regulation, like exchanging all the results from the pilots and aiming for large-scale large-scale industrial projects that may meet an offtake in Europe or Asia, so we can close the business model and sign the project.
Great. Horacio, and the second question that we have for you is, what would the critical next steps be? Maybe talking about the short term, 1 to 2 years, for developing hydrogen in Latin America.
I think that as Colombia is running these pilots, I think we have to do a very big effort in terms of exchanging the knowledge and the results, and making sure, like as an industry, we take those results and they are included in the new norms or regulations. You know, innovation is always pushing for regulation. But I think having a complete set of regulation regarding hydrogen will be not as wise, because we are also learning as we go. So I think pillar number 1 is make sure all the companies making pilot projects share their knowledge, their results, and we kind of develop the regulation accordingly. And I think being competitive in hydrogen will be a consequence of being competitive regarding producing electricity. And right now, the Colombian energy matrix is very renewable because we have hydropower as the base. But we need to push for more solar and more wind power more solutions regarding batteries and have a very, very strong infrastructure regarding electricity generation, and all the management in place, being that said, transmission, distribution, and of course storage. And once we get there at the right numbers, I think that hydrogen will be a natural consequence of that effort, and is what the country and the main energy companies are trying to do at the moment.
Great, Horacio, thank you so much. Last couple of questions for Dr. Leonardo. What is the main objective of having a specific standard for testing materials in the presence of hydrogen, and why are these necessary?
Well, as I told you before, the guide is intended for use by labs and materials personnel to facilitate the conformity in testing. Well, we need to facilitate this, and we need to compare the results and have more discussion about this, and to know better about the fundamentals of the fracture, the mechanical of things, because hydrogen is a very, very, very little molecule, and it penetrates in the metal structure and give us the opportunity to have the fracture of a pipeline, for example. This is the main concern of the people from EPRG in Europe. This is the reason they established some guides for how to manage this, the combination of hydrogen and gas in the pipes that are using for gas pipelines, and put hydrogen inside. So in some cases, we have old pipes. What about the corrosion side? What about the dimension of this pipe now after 20, 30 years? And we put hydrogen penetrating in this how can I say this, in the pipeline. Well, we need to have methods for testing, using tensile and bend beams, for example, or compact tension fracture mechanics of test specimens. This is a very, very interesting task, and the academia is doing this. Very good results are appearing. A lot of events and seminars are now in Europe and Asia, and also in the United States happening.
Great. Dr. Leonardo, second question, what type of damage, degradation, or corrosion can hydrogen in a gas form cause to metallic materials commonly used in the industry?
Yeah. As I told you, the hydrogen embrittlement significantly impacts material engineering by degrading the mechanical properties of metals. This is the main concern nowadays, and we need to know better about the alloys and some very, very interesting field of fracture and fatigue. This phenomenon of the hydrogen embrittlement, this is a terrible name, embrittlement. So this phenomenon can lead to the unexpected failures. This is a problem in the structures. They can open a pipeline. It's terrible. And then hydrogen embrittlement can mitigate it through, how can we mitigate this? Through various methods that the people are studying, using coatings, alloying with elements that trap the hydrogen, or employing heat treatments. So it's really a very interesting challenge for the academia now, and people are doing the best. So this is the main concern. Hydrogen embrittlement is the big task.
Dr. Leonardo, thank you so much for your time, as well as to all of you guys for participating on tonight's panel. And then once again, just for our viewers, to go one more time, Daniel Loaiza, Communications and Marketing at NG, Horacio Pinzon, hydrogen business developer at Ecopetrol, and Leonardo Uro, who you just heard from, global business advisor at Cortez. Before we wrap up, Francesco Solari, CEO of Insmed, wanted to give a few final words.
Thank you, Richard. Thank you, everyone. Well, we have reached the end of this new Inspanat event. We are, as always I said, we turn the knowledge of one into the strength of all. I believe this work that you showed today is very, very interesting for the rest of the world, for our followers. So I would like to express my sincere gratitude to our panelists, Daniel Loaiza from ENGIE, Horacio Pinzon from Ecopetrol, and Leonardo Uller from Cortez for their incredible contribution. And I know very well the fight that you're doing, Leonardo, with the Britman, more than that. It's incredible job, but it's incredible to listen the explaining from Daniel and from Horacio. I'm believer of the great development of hydrogen industry in Colombia and the great job with the storage in electricity in Mexico. So you show three phases, three opportunities, and three realities. So I'm glad and grateful. And I also want to say thanks to our sponsor, BECT, Cortez, another time ENGIE Mexico and Gastech, and to our entire community for joining us in this incredible broadcast. This event, I want to say, is a clear reflection of Inspanet's commitment to spreading the most advanced technical knowledge in the energy industry. Thank you so much. Thank you so much for everyone, and see you soon.
Thank you very much. Appreciate it. The efforts that Inspanet is doing is fantastic. And
you're doing better.
It's a big channel.
Because the leaders are existing. So 3 leaders sharing knowledge. It's incredible. Thank you so much.
Thank you all the team there. Okay. Have a good day.
Thank you so much. Thank you, Richard.
Of course. My pleasure, Francesco. Thank you once again. Thank you, Leonardo, Daniel, and Horacio. Also, one last shout out to our sponsors who we can't do this without: BECT, Cortez, Gastech, and ENGIE Mexico. Guys, thank you so much. To all of our followers, stay tuned. We have some great content coming out this month of September, some really interesting interviews. So follow us on social media, visit our Inspanet platform. If you have any messages, please send us a message. And if you have any questions, please send us a message. And we look forward to hearing you. Have a great night. Thank you.
Thank you.
At BECT, our mission is simple: deliver technical excellence to our clients worldwide. From the oil and gas sector to refining and industrial processes, we provide engineering solutions that make a difference. Our expertise extends to plant services, training, and software tools, always striving to exceed our clients' expectations. At BECT, we combine cutting-edge technology with a team of experts dedicated to safety, efficiency, and innovation. Our commitment to training ensures that our teams and clients are always a step ahead. BECT, more than a company, we are your strategic partner in engineering and plant operations. BECT, good, better, BECT.